All right, let's do the moment of inertia gizmo. So when you go and log in, if you click on Find Gizmos, this is a fun one. Just type in mom, and mom will give you what you need, right? That's probably always true. So moment of inertia, we'll click on this, and then it comes up, and we will launch the gizmo. So as always, under the lesson info, it's always a good idea to click on the vocabulary sheet. There it is. And you can also click on the student exploration sheet. And again, this is the instructions, and it's also where you record your answers and any information that you get, your data. You don't have to print it out. If you want, you can, but you can always just copy it in a notebook, or you can type up your answers. So what this gizmo does is this gizmo gives us a little bit of a practice with something called moment of inertia, right? Your moment of inertia is the rotational analog to mass, right? Recall that mass was your resistance to changes in your motion. So if you have more mass, then it's harder to move. If you're moving and you have more mass, it's harder to accelerate. It's harder to get you to stop or to change your direction. So with moment of inertia, if you have a bigger moment of inertia, then it's harder to change the way that you're rotating. If you're not moving, it's harder to get you to move and to rotate. If you are rotating, it's harder to change the rate that you're rotating. That's what your moment of inertia is. And you can calculate it. It's purely a calculus integration type of problem. In almost every shape that you can think of, someone's already done it. So there's no point in going through any of that derivation. Here, we can pick different types of objects, right? A point mass is just what it sounds like. It's just one point that happens to be rotating around. But we also have some other shapes as well, right? A disc, ring, and a sprocket. And depending on the shape, it will tell you what the moment of inertia is. So if we click right here, it's going to give you not the equation to find it, but it will give you the actual number, the value that goes with the moment of inertia. Moment of inertia is abbreviated with a capital I, and the units are kilograms, that's the mass, and then you've got your meters squared, which is really where those kilograms are distributed throughout that particular shape. So for this particular gizmo, what you do is there's a piston that's over here. When we hit the play button, this will go out, it'll bang onto this part, and it will get this thing to rotate. You can change the amount of energy that the piston will apply to get this to rotate. And you can also change the location of the point mass. You can even add more of these masses onto it. You can put here to show what the moment of inertia is, and you can even put show linear velocity, and I'll show what that looks like in just a second. So this is just the regular setup. I have not changed anything. And if we hit play, you can see, boom, there it goes. And around this thing rotates. So let me just reset it. We can also put show linear velocity, right? This would be your tangential velocity, and here's the radius, which is by that r, right? So it's going to show you what the radius, the velocity is based on where that dot is, and you have the ability to move that around. So now if we play this again, there it goes. It tells you how fast that it's rotating based on the radius that's given. So you can also add these other masses, these other point masses on here, and you can see that the moment of inertia has changed. And if we give it a go now, remember this was at 20 before, and now it's dropped down to just about 11.8 meters per second. We can also move the red dot, so now the radius is out to 6. We can move it all the way into 1. If you want, you can take some of these back, and you can always have, the radius matched up with where the point mass is, but you don't have to. So these are some options that you have. If we go and pick a disc, right, then a disc has obviously different shape. You can change, this is on 5 meters, but you can change the radius of the disc. You can change the mass. You can still show the linear velocity and the moment of inertia. Notice that it changes when you have the settings change. You could do the same thing for a ring, changing the radius of the ring. And then we have a sprocket, which has another shape. Now, we don't have a way of changing the shape or the diameter But what we can do is we can change the mass, and you can see once again that the value for the moment of inertia changes. You can also change the amount of energy that the piston is going to have as it delivers that impact to get this thing to rotate around. So have a little fun with this. Go through the student guide so that you can work your way through this gizmo.